So guys, let's begin with the code. Now this is the very naive approach, right? Naive approach. Now what I have actually said, first we will calculate the factorial, then afterwards we will begin with calculating the trailing cells. Okay. So how we will begin with? This is just the code which I have just copy pasted from the previous video where we have discussed about the factorial. Now here what we will do is first we will initialize a count which is 0. In this count, this is the count actual where it will store the trailing zeros count. Okay, so what we will do is this result which we got, it's actually the final answer after calculating the factorial. Now what we will do is here, what we will do, we will now here we are checking whether the remainder is 0 or not, right? If it is like equals to 0, if it is true, then only it will come inside. Okay, I will show you the example also. What I have actually said, result is equals to result divided by 10. But before that, what I will do, I will increment the count so that it will take the increment the count so that we can actually understand. And here we will return it. So what is happening? Now see, if I'm taking 120, right? Now 120 has been calculated after I got this 5. Now after finding this 120, it will check whether the remainder is 0. Yes, it is 0. If I am dividing this by 10, I'm getting the remainder as 0, right? So yeah, it is true. So it will come inside, will increment the count. Okay, increment the count. Then afterwards, this will reduce to 12. Okay, 120 का था, अभी 12 हो गया because I am dividing it by 10. Okay, afterwards, after this we get this 12 and it will check whether the 12 is having the remainder as 0, and it is not, right? The remainder will be 2. If I'm dividing 12 by 10, so what would be the remainder? 2, right? So it is coming first, so it will not enter here. It will go directly here, and the count was 1, right? It will return that one. Okay. So let us begin. Let us run this code so that let us check whether it is running or not. So this is the fact. Okay. Let us check. Run this code. I will write 5. Type 5. Okay. Then it should come 1. Okay. Now I will type it as 25. We know that 25 factorial is 6. Okay, just a minute. So there might be some overflow issue also here. Okay, so that's why sometimes the issue would be this way. Like there would be issue that there is some overflow or something. Or let me check for a minute. There would be some overflow issue if I'm trying to there is an if I'm trying with 10 factorial, it's already said that the 10 factorial trailing zeros is 2. Okay, so let me check whether it will come right in this program. So if I'm putting 10, right? So yeah, it is coming true. There will be some overflow issue as I have said. So it is the one of the cons in this method, in this methodology or the approach. Now we will check with the efficient approach. The efficient approach, which the one which we have discussed, it's basically dividing. Okay, dividing it, we have to sum it where I will go from 1 to the number which is nearby or has the factor of 5 raised to n. So that n will be coming here. So think about this solution. I will come back in some seconds. So this is the solution which I was talking about. The solution which was finding the power between finding the power of 5. Okay, so we have already discussed there will be 5, there will be 25. So we all know it is just dividing that n number, the factorial, that username, with 5. Also, there is if there is a factor which is more than like more than like it which is reaching 25 or so, so it will include that as well. And further it just cumulative addition. This solution is called Legendre's solution. Okay, in previous video I've already spoken about this. Now let's try with the code, right? So in this code it will just take the same value, which is 5, for example. Now 5, it will start with 5 as well, because we only need to check the 5's powers. Okay, so 5 I, this n is nothing but 5, right? It will not increment more than that. So if its case it is more, then it will we will just be multiplying it by 5. Till that time, result is actual 0 now, but we will add what? 5 divided by 5, which is 1. Okay, so result equals 1 now. Then we have checked it is not greater than 5, so we will return 0. Okay, now let's check with 25. Here first it will check for I equals to 5, then afterwards it will check for 25. Okay, now what will happen? Res equals to res plus n is 25 divided by 5. Okay, so this whole thing, the res is 5 now. Afterwards it will check whether I is less than equal to 25. So yes, 25 is also less, or means 5 is less than equal to 25, and also at the increment level it will just multiply by 5. So 5 into 5 is 25. It will increment, right? So again it will go inside and we'll check res equals to res plus 25 divided by 25. Okay, this I will be introduced to the next value, which is 25. Again 1 will be added, so the answer will be 6. Okay, so let us try with this whether it is working. Okay, so 25, so the answer is 6, right? Now in this case it was coming, right? In the previous code it was not coming. If I'm putting 10, then it should be 2, right? So this way we are ending the training zeros in a fact. It was a very interesting video. And also I already told about the time complexity, right? The factorial would be having the auxiliary space. So here we don't have an auxiliary space, right? It's just time complexity, which is log n. Actually, the thing is actually log 5 base 5n, but we don't write this base and all, so it's log n. Okay. Now, yeah, for that's it. So we will meet next in the video where we will discuss the most efficient way for calculating HCF and LCM. So you guys be waiting. We'll be meeting you in the next video. Okay.